Good morning to all. To, Today let's begin the fourth module. This module discusses about the basics of neural networks. In this module, we will discuss about the biological motivation of neurons, perceptron, activation functions, neural network models, cost function, backpropagation algorithm, and last we will discuss about an introduction to deep learning. So before going to the topic, let's see what is a black box method. For example, neural network model and support vector machine mod or SVM models are considered to be black box method. So these machine learning models are considered to be black box methods because the mechanism that transform the input into the output is unclear by an imaginary box. Neural network. The neural network mimics the structure of animal brain to model arbitrary function, or is simply we can consider that neural network is similar to or it is a copy of animal brain. So support vector machine. SVM model uses multidimensional surfaces to define the relationship between features and outcome. Both these models are highly complex, but it can be applied easily to solve the real world problems. An artificial neural network, or in short ANN. An artificial neural network models the relationship between a set of input signal and an output signal using a model derived from our understanding of how a biological brain responds to stimuli from sensory inputs. A brain uses a network of interconnected cells called neurons to create a massive parallel processor, whereas an artificial neural network or ANN uses a network of artificial neurons or nodes to solve the learning problems. A human brain is made up of 85 billion neurons, resulting in a network capable of representing a tremendous amount of knowledge. Whereas an artificial neural network have been used for over 50 years to simulate the brain's approach to problem solving. Now let's see what are the different applications of artificial neural network. So it can be used for speech and handwriting recognition system, automation of smart devices. Also, this artificial neural network can be used for developing the sophisticated models like weather and climatic pattern, tensile strength, fluid dynamics, and many other scientific and social or economic phenomena. Artificial neural networks are versatile learners that can be applied to nearly any learning task like classification, numeric prediction, unsupervised pattern recognition, etc. Artificial neural networks were intentionally designed as a conceptual model of human brain activity. So now let's see the structure of a neuron, which we are studied in our earlier classes. The main components of a neurons are this: dendrites, cell body, axon, terminal button, axon terminals, nucleus, etc. So in a neuron, in a neuron, the dendrites, this is a dendrite, the dendrite will receive information from other neurons and transmit toward the cell body. So now let's see what is the uses of a cell body. The cell body in a neuron keep the neuron alive and determine whether it will fire or not. Next is axon. The axon is an extinctive fiber that conduct impulses away from the cell body, and transmit to the other cell. Biological neuron function. Incoming signals are received by the cell dendrite through a biochemical process. The process allows the impulse to be weighted according to the relative importance or frequency. As the cell body begins accumulating the incoming signal, a threshold is reached at which the cell fires and the output signal is transmitted via an electrochemical process down the axon. At the axon terminal, this is the axon terminal. At the axon terminal, the electrical signal is again processed as a chemical signal to be passed to the neighboring neuron across a tiny gap known as synapse. to the other cell. So this is a schematic representation of a neuron. All the components of the neuron are listed here: dendrite, axon, axon terminal, cell body, etc. This is another representation of a neuron. This diagram indicates how the neuron will transmit the signal from one neuron to another. This is another representation. This also represents the same diagram as previous one, which also represents the transmission of neuron from transmission of signal from one neuron to the other. The transmission of signal from one neuron to other. This is also another representation of the working of a neuron. Transmission of signals from one neuron to another one is represented here. So artificial neuron is very similar to a biological model. Now let's see how to model an artificial neural network. We can model an artificial neural network by using a diagram known as directed network diagram. The directed network diagram defines a relationship between the input signal received by the dendrites, which is represented as X variables, and the output signal, which is commonly represented as a Y variable. Like a biological neuron, each dendrite signal is weighted, which is represented as W, according to its importance. The input signal are summed by the cell body and the signal is passed on according to an activation function which is denoted by F. This is represented in this figure. Here in this directed network diagram, the variable x1, x2 and x3 are the input signals. x1, x2 and x3 are the input signal. W1, W2 and W3 are the corresponding weight of the input signal. Here W1 indicates the weight corresponding to the input x1, W2 indicates weight corresponding to the input signal x2 and W3 is the weight according to the input x3. Within the cell body, all these input signals are summed up according to the weight and by using the activation function F, it will transmit its output to the next neuron which is indicated as Y. Y is the output neuron and X1, X2 and X3 is the input neuron. A typical artificial neuron with n input dendrite can be represented by using a formula as given here. That is, y of x is equal to f of sigma I equal to 1 to n wi into xi. The w weights allow each of the n inputs that is denoted by xi to contribute a greater or lesser amount to the sum of the input signal. This is all about the basics of neuron. In the next section, we will discuss about the different characteristics of neural network. A variant of neural network each can be defined in terms of the following characteristics, or a neural network consisting of mainly three characteristics. First one is activation function, network topology or network architecture, and training algorithm. This can be discussed in our next section. Thank you.